recording's been started. The primary goal of today's session is to essentially go over three major things. One is recap of the things that are the North Stars and priorities for the project, since a lot of people are new to the project and don't know that necessarily all of what we're actually wanting to achieve and why we're wanting to achieve it. The next is talking about the proof of work PR, which is probably going to be the bulk of this, and then finally Q&A, which will give an opportunity for people to bring up whatever they want to talk about, as well as ask any questions about the overall project and everything. So to start things off again, real quick, going back to this, we had set the North Stars in the original Hypersnap meeting. The primary goal is to grow the network, to make it possible to build a client very simply, and to make the network self-incentivized so that it can actually decentralize. How we want to achieve that, as I said earlier, sorry for repeating myself, but I know it's worth to have it on the recording, is to ship a real query layer, basically meaning to make it possible so that you don't need to have an ingestion pipeline backend of your own in order to build a client. The current architecture of SnapChain basically mandates that you do that. Like, the only way that you can build a functional Farcaster client is to use either somebody's prepackaged software as a service offering that does this for you, or build your own indexer, and that sucks either way. That's one of the things that really irked me whenever Dan said opportunity for another client. Whenever somebody complained about the way things were, it's completely ignoring the fact that there's a huge cost in what was required to build a successful client. So our goal is to make it so that people can build clients and they don't need to necessarily build their own custom backends unless they really want to. The second is to make client building as simple as possible by having a template and SDK experience. So in other words, the primary goal is that someone can build a client over a weekend, and that should just be very easy to do. I think I heard somebody say something, so if you want to stay, go ahead.
I don't think so.
Okay, cool. So the third of the five is to turn channels and curation into first-class primitives. Two different thoughts on this is manual curation and mini app-driven curation. There was a lot of different discussions about how we wanted to achieve this, but primarily the goal is to, bring back the cozy corners angle and to find ways that people can build their own communities, whether it's on a channel or through the way in which they curate feeds, if they wanted to have their own custom feeds. The fourth was mini app on ramp plus distribution. The proof of work PR actually includes the mini app storage data related things. So I'll get a little bit deeper into detail in that when we get to the PR itself. But yeah, the goal is to make mini apps as easy to build as possible, as well as snaps, and be easy to get users. The last route is native monetization plus value distribution primitives, which is probably why some people, some unfamiliar faces, have joined this time, which is because we've already launched the Hypersnap token, and the first few tranches of the retroactive distribution have already gone out. And so the goal behind the Snap token, as some of the infographics and explainers have tried to articulate, is that the purpose of a token is, in the context of a social media token, is to make it possible for creators, curators, mini app developers, Snap developers, and node operators can all earn together in ways that helps reinforce quality as a flywheel, as well as growth as a flywheel. And it kind of answers the question around what would people pay for. And so how that plays out in terms of interactions with the Snap token from users that have it into the network itself is in the form of being able to provide paid access and subscription primitives. So for example, if you wanted to subscribe to a user and essentially vouch for them is the term that we're using in the proof of work PR. That enables you to do so both of you can win together. If you're wanting to set up channels that are essentially, You kind of think of it like how Discord servers or Reddit, like subreddits, have their own communities. If you wanted to boost that community, you could do so in a way that helps the collective channel and community grow together. There's a bunch of other interesting ideas around this. We do have like very mild form of spam control that we're trying to employ with it, and also there's some interesting ways we can handle like really high throughput interactions on many apps. But that's the like big overarching five North Stars. So like if you've been given a any sort of idea from other people about what the intentions of Hypersnap is or uh, why it exists, if it's not these five reasons, you've been told wrong. So just wanted to get that out there so people can understand a little bit better about what we're doing here. Um, so to get into the overall proof of work PR itself, it's a massive PR. So I can understand why a lot of people haven't taken a look at it, and even the um, even the PR or the FIP behind it is also pretty big. So let me pull it up real quick so I can.
Okay, wait, Cassandra. While you do that, okay. So the five North Stars on the first discussion. So this was a meeting that you had on the 6th of January of this year, yeah, right?
Yeah, that's
2026.
correct.
So the number one is cheap real query layer. Stop forcing customer indexers, right? Let anyone run custom queries over cast thread reactions. So basically that's let anyone run real nodes, right? That's the first thing, right? That's
Yeah,
the first, because we're talking about five North Stars, five main things, right? Okay, so anyone can run the backend of the system. So then we have make client building a template plus SDK experience. I can build a client in a weekend. So um, easy to create your own client for this backend, right? So that's the second one. The third one is turn channels and curation into first class primitives. Create
correct. Yeah.
non-gambling paths to discovery and community growth. Uh, what do you mean by turn channels and curation into first class primitives? Because
So
yeah,
um, yeah, on Farcaster, the Nanar owned Farcaster app,
mm,
channels are actually not a real thing. Like they're on Farca like the Nanar backend, but channels themselves don't actually exist. They're literally just like if you look at the cast data underneath the hood on Snapchain or Hypersnap, the channels are literally just a link, or sometimes they're a ERC. I think 721. But at the end of the day, they are a object that it references as the root cast. They call it a parent URL instead of a parent cast ID, but it's just taking advantage of there being a shared anchor across all of those given casts, and then it categorizes them as belonging to that channel. But when you want to create a channel, you have to pay $25 to Nanar, and that's pretty bonkers. There's very few communities out there, or like community-based social media platforms that mandate people pay a fee just to even start building their
yeah.
community. It's very backwards, and it doesn't encourage growth, nor does it actually give something, nor does it actually like feed into the decentralized substrate itself. So like channels, if you want to build a client that supports channels, even today on Snapchain, if you want to build a client that supports channels, you either have to scrape literally all of the channel data from Farcaster and represent it yourself, or you have to basically build an indexer that takes all of the casts from Snapchain, reads all the parent cast URLs, and
Okay, so
finds the ones that
yeah.
meet a certain structure.
So you're really technical about everything, right? And to make it more easily digestible for people that are not so technical about this, you mean that the third North Star is that anyone can create a channel and make it work without all the hassle and without asking for confirmation, without paying. Like basically what happens with Discord, right? You sign up with Discord, you log in and you create your own server, and you can create, and it doesn't ask you for payment, it doesn't ask you for anything, right? You just create it, and that's what you mean by this primitive of first class primitives about channels. Like anyone can create their own channel without having to pay and without having to ask, and that's it, right? I'm
Yeah, that's correct.
understanding. Okay, then so that's great, right? Then we have mini app, on ramp plus distribution. That's the fourth one. Make mini apps easy to build and easy to get users. So what why did you put this in the five North Stars? Do you think that
So
it's hard for me for creators to vibe code a mini app, or I don't know?
in some respects, yes. So this particular thing was mentioned January 6th. This was I think that was actually before. Yeah, that was before the Nanar announcement even. Um, so like it was still owned by Merkel, and even at the time, or at the time, but even now, building mini apps isn't exactly the easiest thing in the world.
Hmm.
One great example of how this plays out. Say you do want to vibe code a mini app. You have a couple of
Hmm.
different options. You have the Nanar App Studio, which is proprietary. It's Nanar. They handle the hosting for you, which is nice. But at the end of the day, like you are coupling yourself to Nanar, which is a
And you're
centralized
giving
host.
them their data, your data, everything. You're giving the idea, the code, everything, right?
Sure, sure, sure. But this is less about like the philosophy and more about like what are the downstream consequences of it. So if
Mm.
you are using Nanar as a host, it is a centralized host. If
Yeah.
you are using Cell, it's a centralized host.
Mm.
And if you are really successful, especially when going the Vercel route, which because having your own hosting that you have control over the underlying code behind gives you a little bit more flexibility in how your apps can work. And so by and large, like yes, there's some vibe coded mini apps from the App Studio, but like when you actually get to a point where you need to start doing more fancy stuff, like you need to have your own database. Like if you're doing a game, for example, you need to represent game state. There's things that you have to do that you just can't do through the App Studio route. You really do have to find another host. When you do that, you are still making certain kinds of commitments in terms of how your mini app's going to work. You're choosing a hosting provider. You're locking yourself into whatever that hosting provider is with their like vendor specific features. And by consequence, it doesn't actually have any impact on the protocol itself. It is just a separate app that happens to bind to Farcaster, but it's still not very easy, and it's also still very expensive. Like I don't
Ah,
know if you've been
okay,
bit
so
by it, but a
wait.
lot of people have been bit by Vercel, like when they have a really successful app. Farcaster
Mm.
or not, like they have a really successful app. The egress fees can pile up really fast from Vercel, and people get surprised with a $50,000 hosting bill.
Yeah. Yeah. So wait. So for anyone who doesn't know, Vercel is basically a company that provides really easy access for developers to deploy a website. So it's another thing. So wait, so mini app on ramp plus distribution is, do you mean that mini apps are going to live inside the protocol itself, or it's going to be a decentralized world of mini apps? How do you see it?
So similar to channels, there's a few different problems. Again, if you want to put a mini app on Farcaster, the mini app spec is open, so you can host it however you want.
Mm.
But when you do that, you're creating that special farcaster.json manifest that makes it accessible to Farcaster clients as a mini app. However, the indexing of that is not on protocol. So in other words, if you want a list of all the mini apps and rank them by popularity and whatever, you either have to build your own backend yet again to scrape all of the cast data and then look at all the URLs and then check to see if those URLs have a Farcaster mini app manifest. And that's, again, as a client developer, that's a lot of work. And arguably, if mini apps are something that we're going to support as a first class primitive of the protocol, we should actually have a way to index them on the protocol. And so part of that North Star is not solving the hosting problem necessarily, but solving the discovery and state management. And so it's kind of half on, half off the protocol. The proof of work PR that I'll be diving into in just a sec basically adds a few small things to the protocol itself to make that work. And how that works is basically like if you create a mini app, you can tell the protocol, this is my mini app. This is, all the info that you need to get. And instead of it being something that you have to rely on your own indexer for, it's actually native to the protocol itself. So it gives a way for you to query Hypersnap nodes and say, hey, what mini apps are there? And it will tell you that. The other side of that that's really important is when you're building a mini app, like say you're building like a super simple one, like you're just building like a tic-tac-toe game, for example, but you want it to be a tic-tac-toe game between players, not just you playing against a bot that you have in JavaScript or something. In that case, you need a way to communicate state between those two players. And so the other thing that's included in the proof of work PR is the integration of mini app state, and that can live on protocol. So similar to how like a decentralized app on Ethereum, like say you're going to Uniswap, for example, you go to the Uniswap website, you're loading the website for it, and it is you're interfacing between the website, your wallet, an RPC provider that relays those messages to the Ethereum network or whichever EVM chain that you're using. And that network holds the state of those tokens and performs the interactions necessary to complete the swap or supply liquidity or whatever. And so similarly, with Hypersnap's support for mini app state, it's the ability for a mini app, instead of having to maintain, a mini app developer having to maintain their own database with like Supabase or something, they can instead actually use the protocol directly as that store. So when you're sharing a mini app, for example, like that tic-tac-toe game, you can actually just share that, very static single page app website that's just the JavaScript, has no real backend minus the static file host. And then the state of that mini app can live on Hypersnap itself.
So are we thinking about having a EVM style contracts for database?
For mini apps, it's very, very like simple. It's a data store. There's no logic involved. For snaps, because the intention of snaps is to actually be like smaller bite-sized composable software that you can share and it will render natively in clients, there is the Snap Compute FIP. I can also drop a link to that. It's where did I put it? I believe it's discussion number 21.
So wait, and all this information is going to live on each Hyper Snap node? Like if you want to use if you want to get input and output data from the node, it will be on the Hypersnap nodes, or it will be a separate node for that kind of backend for mini apps?
No, it would be on the Hypersnap nodes themselves. And you can take a look at the Snap Compute FIP. It is technical, and it needs to be. Like that's unfortunately the nature of the beast. If you're doing software development, you're going to get technical. But the purpose of Snap Compute is to give you a like flexible Turing complete runtime that has limitations on how much compute it can do, because the intention is to make it bite-sized, snackable software that can be shared on the protocol, and
Mm,
the state and those interactions with that data being stored can also occur on the protocol and be validatable. And that's the really important part, because like say for example, back to the tic-tac-toe case,
mm,
say that you're doing a basic dumb data store, but you're doing it for the snap instead. Whereas the mini app has the authority to write the data for the mini app itself. So whoever runs the mini app is basically handling those writes. For the snap, it's the user writing that data. Now, if you're playing tic tac toe between two users, and the snap is encoding the logic of how tic tac toe works, the messages that store that data onto Hypersnap still need to be validated by Hypersnap nodes. So you have the encoded rules of tic-tac-toe, and then the validators are enforcing it just as the client itself is displaying that
mm,
interaction optimistically to the user. So the user places a circle where a circle can go because there's no other object on the tic-tac-toe grid at this point. That's something that you would have encoded as Snap Compute, and that would go both like it would be run by the client and run by the validator, but run by the client just for the sake of so that the client can do it immediately and the user can see that that happened.
And so, wait, is this approach the same as EVM with the contracts, with smart contracts, or is a different approach? Do
It's
we have to
not the
submit like some kind of, or not necessarily submit like a contract, a solidity thing? How will it work in basic terms so we don't go further?
so um, it's I guess one way to think about it. It's not the EVM, but it's
Mm-hmm.
kind of like the EVM. So like
Mm,
if you're familiar with reasoning about that, like that you have a separate virtual computer that is executing those commands in the same vein, yes, it's like that. But is it the
mm,
same set of commands? Is it the same opcodes? No, it's not. It's a different kind of computer that's
yeah.
just meant for small snackable software.
And it's going to be hybrid, so you can have your own database and also you can use the protocol database, quote unquote.
Yes, that's correct. So
Okay.
I'll actually share the. Oh, sorry, wrong tab.
Yeah.
Let's try that again. There. I'll share the Snap compute
Mm,
uh, FIP real quick, because the instruction set, like I said, very simple. It's just a VM, except we do have a few opcodes, and these fall under like syscall, um, to do things like get the user's FID, get the user's profile data, get a cast. Like these are things that can access Hypersnap data
mm,
itself. Then there's stuff specific to user state, and then UI rendering. Because, like for example, the EVM doesn't have anything about UI. Like they shift the burden
yeah.
of UI entirely to the single page app. But what's most important with what you just said right there, which was how does a user or like a builder of a snap have their own database to do certain things and then
Mm,
use Hypersnap for other things? We have the snap call syscall, which lets you actually call a URL with arguments and parameters, and that will let you
mm.
essentially bind the two together.
Oh, and that there's gas and everything. Okay, and why do you mention gas in that?
For the same reason that any blockchain-based protocol has a compute meter, because if you don't have a way to bind compute to a given cost, people would just put shit that
Yeah,
basically
yeah.
knocks those offline.
And how it's going to be paid, that gas?
That would be through Snap.
Through the Snap token.
Correct. Yeah.
Okay. So then we go to the fifth North Star, that is native monetization plus value distribution primitives. So it says The goal is to make it straightforward for creators, curators, mini apps to earn in ways that reinforce quality and helps return artists, answering what will people pay for. So what I understand in this, in the fifth one, and where most people have entered this understanding of Hypersnap and this new fork, is that this is the token, the value token that you will receive or use in order to actually participate in this ecosystem, right? So if you run a node, you get paid for doing this compute that we have talked about. If you want to contribute or uh, use the nodes, you have to pay with the token, right? And so basically, the fifth North Star is money, and money is needed, right? Otherwise, we cannot pay for anything: electricity, internet, um,
Yeah, yeah.
compute, storage, everything, right? So how did you came up with the fifth North Star that is Snap, the token Snap, right?
Yeah, so all of this, like this wasn't the only Hypersnap meeting. There's been
Mm,
some that happened
yes.
since then. But in this first call, this was again before Nanar bought Farcaster.
Yeah.
We were talking about specifically, the really big pain points, and you can actually see like what the um, original pain points being discussed in the meeting were. Like there was a huge at the time focus on gambling and speculation, like the we're
Mm,
a trading app now thing. The anytime that there was any complaint given, it was like, well, go build your own client then. Um, and then the big question of like, well, there were people who were attracted to the platform when we had things like the user leaderboard, and then for mini apps as well, the dev rewards. But they were being gamed pretty mercilessly for both Merkel's Farcaster app and the base app. Both had their own leaderboards, and both of them were getting gamed very excessively.
yeah.
And there wasn't really much of a focus on quality control or how to actually assess quality. And so yeah, through that discussion, it ultimately, like, we were extracting what were the five big ones, like what were the things we could do to really move the needle on user growth, retention, developers, and ultimately decentralization. So yeah, that's the token kind of serves as that unit of interchange to link all of those together.
But wouldn't it be uh, e easier for people to um, abuse the system if they have enough money to buy enough tokens to use the nodes and spam and etc. Like if you have a ton of money, you can just buy snaps and use the nodes, right?
I'm so glad you asked that question because
Yes.
that leads us into the proof of work FIP.
Okay,
Um,
cool. Yeah, that's really important, right?
yeah, so the trick here is that what you're describing is essentially a class of attack. Like in staking based protocols, almost all of them have a
Mhm.
two thirds majority burden. In
Mm.
other words, if a third or more is faulting, you can cause network halts or all sorts of bad things to happen. And so we're not doing that. We're not doing proof of stake. That does not work in this context. So instead, we're doing proof of work, and the way that we're doing proof of work falls into basically three different types of work. Like, what are the kinds of work that can earn tokens? And the different markets are. Let me see if I can find it real quick. I should just search for 50, and that should. Oh, come on. There we go. No? Dang. Okay. Oh, where are you? There we go. Okay, so we have the three different work markets. The first is the data availability, which is the nodes running,
Mm-hmm.
which is essentially 50% of issuance overall in the markets. The second is growth, which is the user growth, like being essentially the growth scoring calculation, which was factored in for the retroactive rewards. Um, and then that's 20% of the overall emissions. And then the third market is application and usage, regarding like mini apps and snaps and so on, and that comes up to 30% of the overall emissions. But the sole goal of this is that, with each being its own reward pool, it incentivizes certain kinds of activities. When we start to add more features to Hypersnap, like the mini app compute, or sorry, the mini app storage and the Snap compute stuff, that's a lot more data that's being put on the protocol. We're already sitting at about 650 gigabytes of total size if you are like holding all history. And Hypersnap holds all history, but I mean like holding all block history as well. And that like is in the long run not tenable. Like this is a network with maybe 10,000 to 20,000 daily active users, and while that's increasing again, and I'm not saying that it's totally us, but like we definitely, like if you look at the DAO chart, you can see that it came, like the spikes that came from user growth began once talk was happening publicly about the Snap token.
Mm-hmm.
Um, as that grows, so too will the rate of storage, and so uh, we need more validators to be able to hold more data, but we also need those validators to be split out into separate shards. And so the way that Snapchain and Hypersnap both work is right now there are three hard coded shards. There's the shard 0, which holds global data, like user information, like what addresses are connected to a given user.
Okay.
Then there's shard 1 and shard 2, which is just literally like taking the user's FID and bucketing it into even and odd, basically. So it splits the user data set into two. But regardless of there being shards, the validators actually hold all of them. So, like, if you run a validator or even a read-only node, you're replicating shards 0 through 2. Whereas in a true distributed model where shards actually mean what shards are supposed to mean, you would have three different nodes potentially run by the same person that are handling shard 0, shard 1, and shard 2. Or yeah, sorry.
Wait, Cassandra. Wait um for simplicity's sake. What is a chart? What is a chart? In simple terms, right? We have the
Yeah,
chart 0, chart 1, chart 2, right? Into the node, right? But for
yeah,
simplicity's sake, for people that don't understand fully the scope of running a hyper snap node.
yeah. So the big thing about whenever you build an application that
Mm,
gets really big in usage, you have to think about how you approach that problem. Like, say that you were storing all your data in an Excel spreadsheet. I know that that's
mm,
not how backends work, but like let's say that for familiarity's sake, you're storing all that data in a giant Excel spreadsheet,
mhm,
and say that you are sharing that spreadsheet with your team, um, and you have a lot of data in that spreadsheet. It's just a big freaking spreadsheet. Um, you have different types of data that you're working with in that spreadsheet, and you're not working on all of that data all of the time. You're just working on some of that data some of the time. And so what you could do is, if you have some kind of way to split up that data, like maybe you're working on a spreadsheet that's like you know recent sales in different markets for your company. So
mhm,
you have your like northeast region, northwest region, you have your southern region, and you have different sections where you're doing the same work, but it's just different locales. You could split that into different spreadsheets. You have your Northeast region, you have your Northwest region, and all of those are different spreadsheets that your team can work on instead of just one giant one. And that's basically what sharding is doing, is it's splitting out the data into separate spreadsheets, for lack of a better word, so that the workload that you have to worry about is smaller. And Hypersnap and Snapchain both already do this. It's just that instead of like actually saying, okay, I have 3 different Hypersnap nodes that can handle each one, it presently is it's handling all 3. So it's kind of a moot point at the moment, but the at least architecture exists so that we can split that out.
Mhm. Okay, yeah. So yeah, let's continue.
Yeah, and so we really need to dive into the full scope of the FIP real quick, because this Google Meet only lasts an hour, plus this meeting was only scoped for an hour. So to run through this real quick, like I said, the big idea is that Farcaster, we're producing a new token, the Snap token. To get tokens, you have to do work. What's that work? Either run a node, help grow the network by being an active contributor on the network, or building useful applications on the network. Each one has its own reward pool split 50, 20, 30. The presence of identity is important as an anti-gaming measure. So to let's see, that is okay. So some of the things that come into play, you can see that there's like a FarQuest and a couple of other places that have had their own markets for selling FIDs. You could, in theory, as a type of attack, somebody could go buy an old FID that has a long, contributor history. And so our anti-gaming properties that have already been put into place with the retro, as well as moving forward, is that transfer events reset that effective age. So if you have a transfer event and that transfer event was not, this isn't in the FIP itself, but it's something that we found a way to achieve. If the transfer event is not bound to an account recovery interaction on the contract, then we basically reset the age to 0 from that point on. Like, it'll start anew in its aging. Um, the way in which like anti-Sybil measures have come into play got pretty complex near the end as we were like finally hashing it out. So unless you want to go through that math, I don't know if that's going to be very fruitful for our time. But the intention is that the approach in which we measure and confirm the interactions between user sets to determine whether or not the user is potentially a bot is essentially a blend of their history, their interactions, and the data that lives on the protocol itself. The only thing that we take off protocol is just this specific transfer event information to determine whether or not the user is basically a sold account. The tokens itself comes over a fixed total supply. It's released on a Bitcoin-style halving curve, cuts in half every 2 years. There's no team carve-out, no treasury, no foundation cuts. All emissions go directly to people who are participating and following the rules, or as Montaluna put it, fuck you, run a node. The first year in congregate with the with the retroactive rewards itself has effectively minted out, or will have effectively minted out, about 25% of total supply, and then it tapers off. But the way that those 3 work markets work, in short, data availability, paid to nodes that store the chain data, proves they conserve it. The network basically has a challenge response protocol that quizzes nodes during the epic to confirm that they are holding on to the data. Answer fast, get paid. Don't answer, don't get paid, basically. The growth is 20% of emissions paid to people who build a healthy social graph through actual, real mutual engagement with credible counterparties. So bots that are doing these weird like rings where they're literally just interacting with themselves basically are nothing. App usage is paid to mini app and Snap developers based on real signed user interactions with their apps. Users sign each receipt, so apps can't fake the data, but many apps are the ones ultimately responsible for posting that data. So it's this
Wait,
two-way
uh,
street of an interact.
I think you're not showing the website. Oh, yeah.
This,
Yeah. That one.
yeah, this is the FIP. I'm giving you a high level summary because this is a very like technically detailed document,
Oh,
and
okay,
if the
okay.
goal is,
Yeah. Oh, yeah.
yeah. Um, as far as like the token mechanics, the main three things, like there's people who have wondered about like staking mechanisms, or whether there's a burn mechanism or anything like that. The key is that staking is essentially a way that you can vouch for new users to help grow credibility, but that, like, outside of that, there's not really a staking part of the token mechanic. As far as the fees go, about 60% of fees that are sent as part of like interactions on the protocol, whether it's because there was a gas fee for Snap Compute, or a data fee for mini app storage, or a anti-spam fee because the message was like super spammy. 60% of that gets burned, 40% of that goes to the block proposer for that round. There's no route to a treasury or anything like that. It's just purely on protocol. Um, as far as like one of the like, it is technically sophisticated, but it is important to understand how it works. The way in which the ERC20 on Ethereum, and when we deploy the same contract to other chains, behaves, there is a trustless bridge approach that we use. And the way that that works is that each contract is identical. The contract that gets deployed to any EVM chain is exactly the same. And the way that that works is that it has a special version of the Mint call, which takes a signed Merkle root that contains bridge related data. And how that happens is the validator logic of Hypersnap itself is engaging in a distributed key generation protocol, which some people on this call have already participated in as part of the Genesis creation. But that creation of that key is used as a constantly rotating key, rotates every epoch, so every 5 days, that is used in a multi-party signing approach when blocks are being validated, to sign over the block itself, plus sign over the root of all bridged token events. And so the token interaction on the protocol itself is basically a list of like, here's the amount of tokens that have been transferred, this is the target chain that it's going to, this is the like target subchain if you're talking about like an L2, and here's the destination address that is allowed to mint it out. And basically that's all the data you need in order for you to provide the root of that data, like the Merkle root. And I'm sorry, but it can't get less complicated. Like I cannot break that down into less clear or more clear terms. You have to be a developer. Sorry. And then there's the distributed key generation key shares that are used to sign that. And so through the process of validation of blocks, you are actually writing the new Merkle root state that users are using to mint out their tokens when they bridge to another chain. And the other way around, much simpler. Burn it. You just burn the token on like the ERC20 contract and use that same key when you're providing the bridge back signed event, and that will allow you to bridge the token back. Pretty straightforward. Why all this matters, though, like it's easy to say, oh, great, the Farcaster network's now in the hands of Nanar. That they're in good hands. Like Nanar has an incentive to grow the protocol to help things go. The reality is that like so did Merkle. Merkle had $180 million from investors, and they had an insane amount of runway, and they just decided to fold. Any Silicon Valley based company, especially ones that have been funded by VCs, is driven to a decision of hypergrowth or death. And if they can't find it, like if they can't just figure out what it takes to do that, then they will fold. Like any responsible like VC driven company will fold if they cannot find a path to hyper growth, because otherwise it doesn't fit the model of VCs. That's just the nature of the beast. So in order to have survivability, we have to be able to grow past NANAR. And so we believe these three different proof of work markets will achieve that. And also, by virtue, give the network a resilience that means that even if NANAR does just tomorrow fold because they decide they can't do it, the network survives. Also, the way that three market approach works gives the ability for incentive alignment in a way that no other social media protocol has quite achieved yet. And so it is a theory. We are pursuing a theory ruthlessly with this, but it's a theory that I believe will work, and we have at least the data to show that so far it is working.
Okay, so Dreadlord has the hand raised. So
oh, okay, yeah. Let me pop back over here and open up this. Okay, ready to go.
Before Dreadlord speaks, we have a time, right? Is it possible that we can create another meeting or for another day, maybe, so we have more time to talk about this? Because this is really important.
Yeah. Well, that's why the main focus was meant to be on the proof of work stuff and not the recap of the North Stars. But we've got 5 minutes. Let's go ahead and just burn through the questions. So go ahead, Dreadlord.
Hey, can you guys hear me?
Yeah,
Yes.
we can hear you.
Hey, awesome. Yeah, sorry for coming in a bit late. I had a bit of a kitchen mishap. I know we only have 6 minutes, so I'll make this pretty quick. I guess my question is someone who's mostly non-technical, mostly designer. I'm working on a client right now. No, I'll listen back to the recording, but out of like everything discussed today, what would you say are like the main points that are most important to understand for someone who's like building a client?
The biggest thing is that if you were to try to build a client today by using just Snap Chain alone, you couldn't do it. Like the client would actually be like it's possible. Like you could run a Snap Chain node, point it at the APIs that the Snap Chain node provides, and do all of it on the client itself. But it basically means like, say you want a feed of all the people you follow. Well, there's no feed API in Snap Chain. There is in Hypersnap, but there's not in Snap Chain. And so in order to construct a feed by using just Snap Chain calls alone, you would literally have to request the user's FID, all of the users that they follow, and then request a list of all the casts of all the users that they follow, which is an insanely expensive query. And it takes like a decent amount of time. You follow 1,000 users, even at like 1 millisecond response times. That's still, a solid second of just calls alone, let alone the algorithm of feed building, just to produce a current feed for the user. That sucks. That's terrible.
Right.
And so Hypersnap's goal is to provide all the APIs required for a client to do that in terms of a client can be built in a weekend. How we first started doing that was by adding APIs that mirrored the NANAR APIs. So if you use the NANAR APIs, you can switch to Hypersnap and you don't have to pay $500 a month. Win-win. But we're extending it further. So the creator of Stupid Social, for example, had a number of contributions that he's made and requested that we've added to the APIs to make it easy to support for his client. And there are other clients as well that are making requests for new features to add, and we're very happy to add them.
Great. I guess, I don't know, more like, maybe I could have rephrased my question a bit better. But for like someone who's just like building a client, and I do intend to build mine on the new fork in Hypersnap. I plan to do that. Is there anything with these newest updates, like technical wise, that client builders should be aware of at the moment?
Oh yeah, absolutely. So for example, Hypersnap, regardless of whether or not your your client interacts with SnapChain or interacts with Hypersnap, doesn't really matter. When you create a client, you're creating a signer for your users. So in other words, you have basically a key that is used to sign messages on behalf of the users. Sometimes it's stored on the client, sometimes it's stored on the back end. Doesn't really matter. All it means is it's a way that you can authenticate that the data originated from the user. or at least should have originated from the user. And clients will accumulate a large number of signers. The reward algorithm for developer rewards sees that and will treat those signed messages by the client as activity by those users that are using that client. And so by virtue of that, it means that it increases the overall proportion of rewards that accumulate to the developer of that client. There's other things that are Hypersnap specific. So like the mini app stuff, the actual like signed messages on protocol. There are things that clients can do that are unique to Hypersnap that increase overall reward share. But at the end of the day, like ultimately what is measured on the protocol is what becomes rewards.
Got it. And just say like, just for now, just as far as like actionable things to do, would you just say like, continue claiming, snap tokens and just stay tuned?
Less than 1
Yeah,
minute to close the meeting.
Yeah. Shit. Yeah. Do that, but also by all means, like jump in the Hypersnap chat and ask questions about the APIs and ask for new APIs if we're not providing something you need.
Okay, cool. Awesome. Thanks.
All right. I think we might have like 1 minute left. Yeah, less than a minute. Shit. Okay. All right. Well, we'll go ahead and wrap it up from here. But if anybody has any questions or isn't in the Hypersnap chat and wants to be added, please reach out to me. I will add you, and we can continue discussions in there. We'll set up another time sometime soon. But I really would appreciate it if folks could take a look at that, the proof of work PR and add their comments.
Yeah. And you can tag me on Farcaster if you need anything. Chat.